Hello students and welcome to the last part of the video discussion for Module 6, and the topic that I will be discussing will be all about the exclusive OR and exclusive NOR gates. So first, let me discuss the exclusive OR gate. So the standard symbol for an exclusive or that is XOR for short, is shown in this figure. So basically, it is just an OR gate, no? Mao man ang OR gate. Dayon, nadungagan lang siya ani nga curve, no? Or kani nga line, no? Para lang ma-distinguish nato kung between sa OR gate and sa tong XOR nga gate. So, the XOR gate has only two inputs, so na-limit lang siya into two inputs, unlike sa OR gate and AND gate, no, nga it can have two or more inputs. No, there is a XOR nga gate, it only limits to two inputs. So the exclusive OR gate performs the modulo 2 addition. So I will discuss this later sa application aning XOR and XNOR. So the output of an exclusive OR gate is high only when the two inputs are at opposite logic levels. Meaning, if dili sila the same, no, opposite ilang level, so 0 ug 1 or 1 or 0, then it will output into a high, no? Then otherwise, no, if the same ang ilahang input, so let's say 0 0 and 1 1, then iyang output kay low. Okay? So here I have these four possible combinations of your inputs, natay low low, high low, low high, and high high. No? Unsa ganito, basta opposite ang ilahang inputs, just like this one, high and low, it will result to a high output, no? The same with low and high, no? So ang iyahang pong output kay high. And if the same naman ang ilang inputs, then it will result to low, no? The same po dani sa high and high, low iyahang output. So this is the truth table for your exclusive OR gate. So these are the four combinations, no? So again, if opposite ang ilang input, then that is the time nga imong output kay high. Okay? So kanilang man nga combination, ang opposite ang atong input, then that is only the time nga high siya. Okay. So example, so a certain system contains two identical circuits operating in parallel. So two identical circuits, meaning you can identify or you can distinguish the two circuits, no? Kay identical man, meaning makabalo mo kung ah unsa to siya nga circuit, no? Lahi lahi si circuit A sa circuit B, no? So they are operating in parallel. So as long as both are operating properly, then the output of the both circuits are always the same, no? Kay parallel man sila. Then so kung properly sila nag-execute, then or nag-perform, then ang output is the same, no? If one of the circuit fails, then the output will be opposite to the other one, no? Since they are operating in parallel, then so if nadyoy something sa isa ka circuit, then um malahi jud ang iyahang output. Okay? So devise a way to monitor and detect that a failure has occurred in one of the circuits. Okay? So mag-create daw ta, no? Og circuit nga unsa na to magpagkabalo nga in sync ba gyapon ang atong duha ka circuits, no? Are they still in parallel or dili, no? So for the solution, so you have here your block diagram sa imong circuit A, then block diagram sa imong circuit B. Then if ang isa is not operating properly, no? Kung high ang isa, then if it's not operating properly, then ang iyadang output kay opposite atong imong isa ka circuit. So that's why we have a low here, for example. Then the output for that sa to sa XOR gate, if opposite ang ilang inputs, then it will have an output of high. Then here, ang high kay nag-indicate siya as failure, no? Naay something sa imong circuit. But if both of your circuits are high or both of them are low, then it will result to an output of low, meaning walay failure nga nahitabo. Okay? So, the exclusive NOR gate naman, so this is just actually an OR gate with an inverter, no? Nga cascaded ang inverter. So, pares ra siya sa AND gate nga nahimong NAND gate ug NOR gate nga ay OR gate nga nahimong NOR gate, no? So, ang XOR nahimo siyang XNOR. So, nala siya bubble sa imuhang output nga side. So, we expect, no, kay since namatay bubble, so this means an inverter. So, we expect that everything sa tong output kay just the inverse of your XOR, no? Kabaliktaran ra siya sa imong XOR. So, sa XOR, if opposite ang imong inputs, it will result to a high. Dari naman, if kung opposite ang imong inputs, it will result to a low, no? Then kung kaparehas naman sila og inputs, then that's the time nga ang imong output kay high. Okay? Nga na lang kadali. So, in terms of the waveforms, no, so kung nakay XOR dere, no, imo lang timan-an nga ma-high ra siya if opposite ang imong duha ka inputs, no. For example, kani nakay duha ka inputs, no, then only kani nga time, no, time interval 2 and time interval 4 kani, no. If you notice, this is high, this is low, then this is your high and this is your low. If you notice sa input A, low siya, then sa input B kay naka-high siya, no? So this is opposite. That means your output here is high, no? Na siya sa taas. Then the same with the time interval 4, no? Natay input dari sa A nga high, sa B kay low, no? So mao nang high ang ato ang output. Then for time interval 1 and 3, so both of our inputs are the same, no? Kani kay 1 ug 1 meaning high ug high. So atong output kay low, dari kay 0 ug 0. So our output here is low. So nga na lang. So another example, so here nadapuntay duha ka inputs because limited lang sa duha ka input ang XOR, but this time kay naatay XNOR and XOR, no? Kaning bubble, this is the XNOR. So this means duha ka output waveform ang ato ang kwaon, no? So we expect, since XOR and XNOR are just complement they complement each other, no? So they are just the inverse of one another. So ang atong gi-expect ana kay ang ilang output kay opposite pod, no? Kung high ang sa imong XOR, so low na siya sa imong XNOR. So again, sa imong technique lang ani, just answer one of the circuits. So natay kung tayo for example si XOR ang ato ang ansiran. So unsa gito sa XOR, dapat high siya if opposite, no? Kung 1 ug 0 or uh, ay 0 ug 1 ug 1 ug 0, high siya, no, sa XOR. Then if the same siya, ay ara siya ma-low. Sorry. So kana lang timan-an. So the same 1 1 then 0. So for time interval 1, so natay high, low, high, low. So this is your high, then this is your low. So for time interval 1, so high ang A, si B kay low. So we expect that our answer here is high, no? High atong output. This time kay high si A, high si B. So of course our answer here is low. Then kani kay low ug high. So high atong output. Dari kay low and low. So this one, so low pod ang ato ang output, no? This is our X, B, and A. Okay? Then, ta, this is high, this is low. So, high and low. So, output na to is high. So, manang high atong answer dari. We have low, we have high, no? So, low and high. So, results niya kay high, no? Then, to write the answer of your XNOR, so kabaliktaran lang. So nag-start siya sa low, so sa imong XNOR kay nag-start na pud siya sa high, no? So high din padung si low, high na pod low. So kabaliktaran na siya sa waveform sa imong XOR. So ingana lang kadali. So you answer practice problem 12. Then here's the 2-bit modulo to adder that I have told you earlier. No, so this is one of the applications sa imhang XOR. So an XOR gate can be used as a 2-bit modulo to adder. Modulo 2 meaning there are only two inputs nimo, no? So recall in our module 2 that the basic rules of binary addition are as follow, no? Kung so mag-add ka 0 plus 0, so lahi si binary addition sa Boolean algebra, no? Katong sa Boolean nga addition nato. So sa binary, kung 0 plus 0 that is equal to 0, 0 plus 1 that is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 0 carry 1, di ba? This is the binary addition. Sa Boolean natong addition kay 1 plus 1 is equal to 1 na siya diretso, no? So an examination of the truth table of an XOR gate shows that the input is the binary sum of the two input bits, no? So the same ra siya sa atong XOR. Di ba, this is the truth table of our XOR, no? Kung i-add nimo, so 0 plus 0 kay 0, 0 plus 1 kay 1, 1 plus 0 kay 1, then 1 plus 1 is equal to 0 carry 1, no? In that case where the inputs are both ones, the output is the sum uh the output is the sum 0, no? But you lose the carry of 1, no? Kay 0 man then carry 1, so tanggalon nimo ang carry. So basically daw ang XOR pwede siya mahimo nimong modulo 2 adder, no? Kung mag-add ka og binary nimo, duha ka binary nga mga digits, no? So this is the illustration, and this is used in the CRC system to implement the division process that was described in the module 2. So muna akong gingon ganiya 0 0 i-add nimo, add the output or the sum niya is 0, 0 plus 1 is 1, 1 plus 0 is 1, then 1 plus 1 is 0, that is without the carry 1 nga bit. Okay? So this is the XOR gate nga application as sa to 2-bit modulo 2 adder. Okay? So for your assignment, so wala lang tayo seat work, assignment 6, answer this following questions 1 to 10, then wala tayo quiz pero na tayo seat work. So seat work, answer problems, practice problem 1 to 12. No, dagan-dagan dyan ang nga module kay there are 3 parts. So no quiz for this module, only the seat work. So seat work again, practice problems 1 to 12 in this module. Then you have this assignment 6. So other details will be posted sa atong G Classroom. So that is all for the module 6, and that will be the end of the coverage of our midterms, no? So the coverage sa tong midterms will be all about logic gates, no? Kay sa module 7, that will be another unit. So unit 3 module 7 na siya, and that is another topic, but still kuan siya, no? Connected lang siya sa ato ang na-learn ani. So para dili mo malibog, no, ato tong lahion og assess ato nga mga topics. So that will be all. Thank you guys for listening.